expensive science project subsidized entirely by people buying graphics cards to play PC games. In 2012, an artificial intelligence competition in Toronto called ImageNet changed the trajectory of the company. The challenge was to write software that could identify objects within millions of images. Today, NVIDIA is valued at $5 trillion. They manufacture the hardware that swallowed the artificial intelligence market whole. But the company building the infrastructure for the most advanced data centers on Earth began by building circuit boards so teenagers could play video games. The connection between those two realities is CEO Jensen Huang. His early life involved immigrating from Taiwan at age 9 and attending a strict reform school in Kentucky, where he spent his days cleaning bathrooms. He was thousands of miles from home in an environment where survival depended on an immediate and total calibration to his surroundings. By 1995, Huang and his co-founders had quit their jobs and pooled every dollar they had to launch their first product. They bet their entire bank account on a single graphics chip called the NV1. They engineered the NV1 to render complex curved surfaces, but right as they launched, Microsoft published the DirectX specification for Windows. Microsoft decided that future 3D graphics would be built out tiny, flat triangles. NVIDIA had confidently spent 2 years building a piece of hardware for a world that suddenly did not exist. The chip flopped. In the semiconductor industry, getting the architecture wrong even once usually means your company vaporizes. By 1997, NVIDIA had exactly 1 month of payroll left. Their only lifeline was a contract to build the graphics processor for Sega's upcoming Dreamcast console. There was a major problem. Sega's architecture relied on the same dead-end curved surface technology that had just ruined the NV1. Finishing the contract meant wasting a year building obsolete hardware. Canceling it meant immediate bankruptcy. So Huang flew to Japan, told Sega's CEO the chip was a dead end, and advised him to cancel the contract. Then he asked Sega for the remaining $5 million as an investment to start over. Amazingly, the CEO said yes. That $5 million bought NVIDIA exactly 6 months to build a triangle-based chip from scratch. The resulting Riva 12 worked, selling 1 million units in 4 months and pulling them from the brink. By 1999, they capitalized on this momentum by launching a chip that handled complex 3D calculations on its own, a component they called the Graphics Processing Unit, or GPU. To understand why the GPU became so valuable, look at how traditional processors work. A central processing unit, or CPU, is built for linear computing. A CPU acts like one incredibly capable employee, handling complex tasks sequentially, one by one. But a GPU operates like 10,000 interns, running thousands of tiny calculations simultaneously. This is parallel computing. NVIDIA perfected this massive parallel architecture to render digital explosions and lighting for gamers. But a chip capable of calculating millions of pixels at once is naturally suited to simulate molecular biology, complex fluid dynamics, and eventually artificial intelligence. In 2006, Huang noticed this potential and committed roughly $500 million to build CUDA. This was a software platform designed specifically to let academic researchers and scientists use NVIDIA's gaming GPUs for general-purpose supercomputing. This area chart charts NVIDIA's income over 6 years. The growing green area represents the highly profitable gaming business. The flat line at the bottom is CUDA. For over half a decade, it generated virtually zero revenue. It was a massive, expensive science project subsidized entirely by people buying graphics cards to play PC games. In 2012, an artificial intelligence competition in Toronto called ImageNet changed the trajectory of the company. The challenge was to write software that could identify objects within millions of images. A team from the University of Toronto found a way to win. Previous researchers had spent years manually coding rules to teach computers how to recognize edges and shapes. The Toronto team, using an entry called AlexNet, bypassed manual coding entirely. They fed massive amounts of data into a neural network and let the machine learn the patterns itself, crushing the runner-up's accuracy rate. Training a neural network requires running millions of distinct simultaneous calculations over and over again. It is a brute force mathematical workload that perfectly matches the exact parallel architecture NVIDIA had spent the last several years refining. The AI labs at Google, Microsoft, and Stanford immediately began buying up NVIDIA's hardware. The 6-year science project had pre-built the hardware infrastructure for an industry that was finally ready to emerge. By the 2020s, every major tech giant was building their future on NVIDIA's foundational computing architecture. This absolute scale of market control made their competitors nervous. In 2020, NVIDIA attempted to buy ARM, the British company whose architectural DNA sits inside of virtually every smartphone on Earth, for $40 billion. The tech industry, alongside regulators in the US, Europe, and the UK, united to block the deal, forcing NVIDIA to walk away. This map illustrates the global flow of advanced semiconductors, and it shows exactly what happened when geopolitics intercepted NVIDIA's supply chain in 2022. Washington stepped in, blocking exports of NVIDIA's most powerful AI chip, the H100, directly to Chinese tech companies. NVIDIA responded by doing exactly what they had done since the 1990s. They engineered around the obstacle. They quickly designed the H800, a slightly weakened version of the chip specifically calibrated to stay legally under the threshold of the new U.S. export restrictions. As we see on this graph, as restrictions tightened in late 2023, domestic demand from developers building large AI models stripped the factories bare. The surge in orders sent NVIDIA's market cap straight up to the $5 trillion mark, pushing its valuation past Apple and Google. A company that once faced bankruptcy over quadratic mapping now sits at the center of a global technology war. NVIDIA's ultimate advantage is an extreme organizational capacity to adapt to whatever reality the market throws at them. They proved that survival is the most lucrative algorithm in business.